Please welcome Maurizio Cosello.
Good afternoon and welcome. This presentation is about how our company used the Aras functionalities to develop a process which covers the change management across the engineering and the production. So following a short overview on the company and the products we make, we will see why the Aras project started. We will talk about attributes management and how they integrate with the ECO process. And then we will see the solution we developed to go from the engineering bill of material to the manufacturing bill of material. And after having a look at what happened when we actually started using Aras, we will talk about the following developments we did. And then the last part is about our future plans with Aras and some final thoughts on what we achieved and what we learned so far. So a little bit about the history of the company. IWT is part of a family-owned group which was founded in 1949. The production of washers started in 1992 as a division of the company, and then in 2000 the division became a company on its own, specialized in design and manufacturing of a washing system used in lab animal facilities. In 2008, we have another important milestone, the first washer for the pharmaceutical production. This was the beginning of a new product line, which constantly grew in the last 10 years and is now 25% of our turnover, with a very good growing rate of 30 to 50% per year. A bit about our products. We sell products worldwide, and we have more than 36 machine models for the lab animal market. They range from standalone washers to complete automation system and plants. The number in the pharma market, we have 9 machine models ranging from washing of parts or bins to cleaning in place of production equipment. The number of units for each model is generally limited and ranges from 5 to maximum 80 units per year. Most of our products are configurable and based on modular design, but at the same time we customize a lot with over 60% of our production containing solutions which are engineered on order for the single unit. So before introducing Aras, we were relying on our legacy PLM, which was used only to manage CAD structures and associated versioning. We had a tool to transfer new parts and bill of material to the ERP. But apart from that, everything was relying on manual activities. Part classification was very limited and based on rules used on the naming of part numbers. We had to rely on manual data entry to ensure consistency between CAD and ERP data. And our engineering BOM structure with the associated CAD structure was compromised, so to be able to use it also for the manufacturing process. The product platforms were becoming more and more complex with increasing compromise on the BOM structures to cope with both engineering and increasing manufacturing need. This aspect was causing growing constraints the design activity, in particular when we were dealing with customizations to be done on highly standardized product platform. Beside that, non-CAD documents were stored on network folders, which was becoming more and more an issue with the growth of the production for the pharma market and the need to be in compliance with the regulations of that business. Last but not least, access to data required a high level of product knowledge, and this was very inefficient and also frustrating, both for those looking for the information and for those who had to provide this information. So starting from this point, we decided we needed to have something better. The Aras project started with the target of addressing the biggest pains and rearranging the existing information, so to have them merge with the new data which would have been entered from that moment. Therefore, we wanted to migrate all existing data and establish improved classification, both for new parts but also for the migrated ones. We wanted to provide automated checks on data completeness and consistency, so to increase the quality of the entered data. We wanted to make, as I said before, the engineering BOM independent from the manufacturing needs, which was probably one of the biggest constraints of the legacy platform. And we wanted to establish a process which would allow to release of engineering packages down to the production. At the same time, we want to support our engineers in entering more data and more accurate, but we didn't want them to lose their focus on the design activity. Last but not least, we wanted Aras to become the unique source of information for what concerned the part data. So the project started looking at how to migrate existing data. We migrated more than 100,000 parts from the ERP and more than 280,000 CAD files from the legacy PLM. We created relations between the two worlds and we populated all attributes. We then defined almost 500 classes in 5 levels, and we were able to assign classification to over 95% of the existing part. This was a very demanding activity, but the results, given the source of data we had, was surprisingly accurate, with virtually no need to rework the data we arranged. After addressing this aspect of the project, we started looking at managing part attributes and the additional data entry needed when creating a new part. With over 20,000 parts being processed every year, we needed a solution where the additional data was entered without producing any overhead on the design activity. We identified more than 30 attributes to be managed, and to ensure the quality of the design, we need to keep our engineer focused on their main activity, which is designing. At the same time, to have quality data, we needed information to be entered at the point of the process where the information is generated. What we did after identifying the essential attributes for each phase of the process was to classify them based on their own origin and purpose. So general data, classification information, technical data, and manufacturing data. And then we worked in close contact with the users, and we made several tests to ensure that the data entry process was consistent with the design process. Having done that, we assigned ownership to each attribute to ensure clear responsibility, and we provided defaults to assist users where possible. On the contrary, we didn't provide any default where we wanted users to take a real decision. After addressing the attributes, the next step of the project was to work on the manufacturing BOM. As I said before, the main requirement for us was to make the engineering BOM independent from the manufacturing BOM, so to allow production engineers reworking the bill of material structure, also based on changes which can occur on the production needs without creating constraints or worse needs of changing the engineering BOM. Because of the level of complexity of the project, we decided to focus on the most common issues we were having in this regard, which were adding the raw material to the engineering BOM and adding additional intermediate levels to the structure to manage manufacturing in intermediate phase, or to group components which are either sourced or manufactured as a package. More complex functionalities were left for future developments. The solution we chose was therefore to avoid a separate structure for the manufacturing BOM relationships and to use attributes on the engineering BOM relation and on the parts to address the mentioned needs. Raw material is calculated based on attributes populated in the SCAD information, and then is sent to the ERP as a bill of material relation, even if it is not inside Aras. And on the other side, EBOM relations, which are replaced by MBOM items, are marked within the EBOM and not transferred to the ERP. Manufacturing parts are then linked to the associated engineering part with a reference, so that in case of revision, production engineers are forced to review the consistency of data between the manufacturing bill of material and the revised bill of material. This solution, in combination with the DCO process, which we will see in a while, allowed us to achieve all the required functionalities without creating a separate data structure. After defining the data structure, we moved to the custom ECO process, which is the workflow controlling the release process of an engineering package from the design and through the production engineering. The process, as you can see, involves several steps from the definition of the top elements involved in the change, the automated collection of affected items associated with them, the validation of engineering data, and the completion with the manufacturing information before the items are released to the ERP. This is also the part of the project where the most complex functionalities have been developed. The ECO workflow we developed does not interfere with the design activities, meaning that users define the top-level parts of the structures being processed and are then allowed to focus on the design activity without further interaction with the ECO process. When the design has been completed, affected items are calculated by Aras when the process moves to the appropriate phase, looking at the structures of the engineering BOM and of the CAD structure. The relevant release or revised action are therefore automatically identified. The process then moves to the production engineering, where design information and CAD data are frozen, and the production information, including the manufacturing BOM, are populated. On each step of the process, a set of more than 20 validation rules check that data is complete and consistent, and warns the user in case unusual data is identified. With complex structures, this automated checks and even more the warnings for unusual information proved to be one of the key factors in ensuring an efficient flow of the process and preventing reworking because of missing or inconsistent information. After completing also this part, the core functionalities were ready. We migrated data into the new platform, and it was time to switch on the new application. Because of the heavy changes introduced by the new process, it was necessary to disable the legacy ERP interface for parts and bill of material when Aras was activated. There was therefore no backup functionality, and release of any new or revised part had to be processed through Aras from day one. The system was started at the end of August 2019, and no major issues occurred. In 2 weeks, design activities were basically back to normal operation, and after another 2 weeks, the entire ECO process was operating in normal conditions. From the very beginning, when we had some technical issues because of ECOs not being released to the ERP, we could see the benefit of being able to monitor and prioritize the status of the engineering packages based on the business needs. Coming to some results of this first step of the implementation, after 1 year, over 25,000 parts had been processed with Aras, with increased flexibility, additional information available, and very important for a small organization as we are, without any significant increase in the workload. Revisions for inconsistent data almost disappeared, and we have now Aras being used by 80% of the company employees, with people now searching for information in Aras rather than asking around for this information. After this very good start, we used 2020, focusing mainly in completing some side activities and in tuning the functionalities. We moved technical documents, non-CAD technical documents from network folders to Aras at the beginning of 2020. We then developed an automated system collecting the purchasing documents to be sent to suppliers when buying components or subsystems. This functionality alone saved one equivalent person of activities with no added value, and drastically reduced non-conformities due to superseded purchase documents. In March 2020, it was the beginning of the pandemic phase. We went completely paperless with the ECO process, and we also started some tuning on the ECO process itself, and most of all on the validation rules I described before. This allowed us to reduce by 15% the number of change orders requiring reworking along the process. In January this year, we had an additional functionality which on documentation, which allowed us to move all the project documents, so not only the technical one, into Aras. So now Aras is a solid tool within the company which manages part, CAD data, and all projects documentation, and we are now looking at how to expand it and use and which are the highest priorities in doing new things with it. We have some area of the workshop where we are experimenting paperless production, and we plan to complete the process around the middle of this year. We are in the process of the first version upgrade, which is scheduled for June, and we are looking at the new functionalities available with the new version. Requirement management for the pharmaceutical marketing, product configuration for the most standardized products, and after-sale processes, which at the moment for us is mainly focused on spare parts management and product upgrades after the machine delivery. So some conclusion at the end of this journey, and some final thoughts on the results we achieved and the lessons we learned. Aras made product data available and accessible throughout the organization. This sounds simple, but it is really a very important result. The additional processes we are mapping inside the platform and are quickly turning this platform into an enterprise platform which is managing all the product aspects. And we learned that listening at the user voice allows to develop an interface which can be at the same time efficient in terms of data entry and ensure very, very good data quality. We mapped the change process from the design down to the release to production, and this allowed controlling the entire process and while keeping single activities independent. We built functionalities. This is very important in my opinion. We built functionalities which were tuned on the actual business needs, We kept the complexity low to exactly what was needed, and this proved to be very effective and immediately understood and accepted by the user. I think that this is one of the main reasons for the success of the platform inside the organization, and this is also the aspect which is giving the highest benefit in the long term. This was all about the history of our project. I see that there are some questions. I will go through them in the coming days, and I will provide you with the feedbacks. Thank you very much, and goodbye.